So let's begin today. Today, the first session, we will talk about how to capture distributional issues in multidimensional poverty. If some of you want to include them in one day in your presentations, that's fine. We'll be very glad, but no pressure. And in the second session, Buba will go through the regression analysis. So these are for the first two sessions, two lectures today. So the main sources for this lecture, of course, our book. It's chapter 10.1, which is given as the third one. There's a paper, and that particular section is motivated by a paper that I worked jointly with Sabina, which is also available from the website, and we hopefully will post a modified version soon. And of course, there is another paper by Sabina and James Foster. So what is the motivation for this lecture? We talked about initially that how you measure poverty, or how poverty is assessed, how the tool is used, affects the incentive, policy incentive, right? So if we use, for example, a headcount ratio just to measure poverty, assess poverty, what kind of incentives do we generally give to policymakers? If we just use headcount ratio, which just counts the number of poor. Yes, please?
To help the ones that are just below the poverty line?
To help those that are just below the poverty line and deliberately ignore those who are probably the poorest of the poor. If we just look at intensity, incidence and intensity, that also definitely does not discourage them to help the poorest, but it's also neutral. You help whoever you choose to. And when the consideration of inequality comes into play, definitely then the distributional issues comes into play, then definitely the incentive comes to help the poorest. And that was the motivation of the Foster-Greer-Thorbecke measure, which is also called FGD2 in the unidimensional context. But now we are in a multidimensional context. And of course, following Jenkins and Peter Lambert's 1997 work, they are called 3 I's of poverty. Okay, it's incidence, intensity, and inequality. So the question today is how to incorporate inequality in the multidimensional framework, and then especially we will be focusing on how it could be done in the counting approach framework, when we have ordinal variables and when we are converting everything into 0 and 1. Relevant properties that we have already discussed on the first day, just to remind you, weak transfer in the multidimensional context means an averaging of achievements among the poor should reduce poverty. So that means if you have same incidence and intensity, then if you take an average, okay, if you do averaging in reducing inequality among the poor, distribution the achievements among the poor, then that should also reduce the overall poverty. We had deprivation rearrangement. That means if the deprivations are rearranged among the poor through a correlation decreasing rearrangement or association decreasing rearrangement, then depending on whether they are substitutes or complements, poverty should decrease and increase. So these are the properties that we discussed, and especially for deprivation rearrangement and converse deprivation rearrangement, the results actually came from Bourguignon and Chakraborty, motivated by Atkinson and Bourguignon's work way back in 1982. To give you, remind you the examples. So one was like this. So you had an achievement matrix, which is suppose X, which is this one. You multiply by a bistochastic matrix. For a bistochastic matrix, the row and the column, each of them should sum up to 1. So what it is doing here, it is just averaging the achievements of these two persons. You see 4, 3, you get 3.5, 3.5. 4, 5, 4.5, 4.5, and 2, 4, 3, 3. So this is sort of an averaging going on. And the idea is that yes, of course, if you have larger inequality, if you move from here to here, definitely it should cause that should be reflected in poverty measure. So in societies where even if you have larger disparity in achievements among the poor, it should be reflected in the overall poverty measure, and why not? And the other, the transformation, rearrangement among the poor, was this example. Can you tell me in X or in Y, where do you have larger correlation or association between dimensions? We have seen that matrix earlier. Which one has larger correlation? Here you see 2, 3, 10, 4, 3. So 2, 3 and 4, 3, they are not ordered. So they are actually a discordant pair, no? Remember the discussion from yesterday or yesterday, that discordant and concordant pairs? So these two pairs are discordant because here for this person this is higher, lower, and this is higher. However, here they are concordant. So definitely this matrix has higher pairwise association or correlation between dimensions. Okay, so if you move from here to here, it's called an association decreasing rearrangement. If you move from here to here, it's an association increasing rearrangement. Okay, so these were the examples that we presented in the first class, and this is how generally it has been suggested to include these two different kinds of inequality among the poor. The problem is that, and there are several measures, as if you look at the distributed chapters, the chapter 3, the axiomatic measure sections, you will find the discussion of all these different measures that satisfy either one of these properties or both these properties. It's a bit demanding in a sense, it requires cardinal data. So if you saw that, right, you have continuous data and then only you can do the averaging. If you have cardinal data and you have 3 categories, what do you mean by averaging? There is no category in between. Okay? So they are not acceptable, these properties. They do not really do justice to measures based on counting approaches. What to do here? We also discussed then, where did it go? We also discussed dimensional transfer, okay, which was mostly relevant to counting measures when you have ordinal data. And the idea was that poverty should fall whenever the total deprivations among the poor in each dimension are unchanged, but are reallocated according to an association decreasing rearrangement among the poor. What it does is that it captures inequality by looking at the extent of joint distribution. Let's go back first in this example. If you look at this example, here definitely a association decreasing rearrangement has taken place, but the deprivations were not swapped, right? They were already deprived in this dimension. So if you convert this matrix to a 0-1 matrix, will you see any difference? No. So had these two variables been ordinal, this kind of switches won't make any difference. So it is not possible to do dimensional transfer in this kind of situation. So what does dimensional transfer require? Look at this example. Right? Suppose you use equal weight, suppose you use union approach, just for simplicity. It holds for everything. Now if you look the G0 matrix of Y and G0 matrix of X, which one do you think has more inequality among the poor? Suppose you have it, yes? X is more unequal in that sense, because you have somebody who is really deprived in all dimensions, somebody is deprived in one, whereas in another society they are deprived in 2. So the idea is that if you have this kind of transfers, then it should be reflected in a poverty measure, or you should know that this is happening, because if you measure M0 A, what is the M0 of each of these matrices?
I'm trying to understand things by trying to look to reality. Because if your one is one person, the second one is another person.
Second person
Yes.
and the third person.
Those permutations, it means that, what does it mean in reality? Because
It is not permutation. It is not a permutation does not change the achievement profiles of each person. Here you are switching. So you suppose you take two societies. It not necessarily that one society has been obtained from another society over time, but suppose you find two societies. One society is X, one society is Y. Would you just say that the poverty situation are identical in these two societies? That is what I am trying to say. So it is not that necessarily over time you are transforming one society to the other, but also at same point of time you see this. And even if this happens, even if a particular group in one country faces all deprivations, okay, somehow it happens, they become poor. Even then, it is hard to argue that poverty has not changed in these two societies. You should be able to say no, situation has got worse. They are not the same. Okay, so that's what we are trying to say here. So these two matrices are not same, not identical. But if you compute M0, what would be the M0? We just use union approach. What is the M0 of these two? Sorry? Okay, are they different? Incidence, are they different? Intensity, are they different? Why? You are looking at average deprivation counts among the poor. 1 plus 3 over 2 and 2 plus 2 over 2. There is no difference. So if you look at MPI, they will remain same. If you look at intensity, they remain same. You know, incidence and intensity, they are all same, but these two societies are not identical. This is what we agree, all agree. Right? Very well. Now, if you look again at another example, suppose here you have like the examples that you are working, that you are you are going to present. So suppose you have 10 indicators and you just weight them equally. Okay, so their deprivation scores lie between 0 and 1. So 0, 0.1, 0.2 and so on, right? And suppose k equal to 0.3 now. So we move from a non-union approach to an intermediate approach where you have a k cutoff. How many of them are poor?
4.
So these are, you have the exactly. So you have the deprivation score vector k equal to 0.3. So you identify the last 4 persons as poor. Now suppose you have two different timelines. And suppose these were two countries having this equal deprivation score, and two countries take two different paths. And in one country, over time, you have one person definitely has become non-poor, and for this person, you have a reduction by say 3 deprivations, no change for these two, and you have another society where you have reduction of 1 deprivation for all. Again, the question is, similar reduction in incidence and intensity, incidence from 4 over 6 to this, intensity is also like the same. What about inequality? Again, are they the same? So the distributional issues are there that cannot be captured just by looking at incidence and intensity of an MPI which is a product of these two. And the question is how to incorporate that distributional issues, because it is hard to argue that you leave the poorest behind and even then claim that you have done a justice by reducing your poverty. So the question, how do we incorporate inequality or distributional issues in poverty measurement? How do you, the objective is poverty reduction. The objective is not to reduce inequality among the poor. Okay, just take the money from the richer poor, give it to the poor poor. No, that is not the objective. The objective is definitely poverty reduction, but just making sure that the poorest of the poor has been benefited from that. It is not that you have just left a big group because they are marginalized behind, and then even you are claiming, I have done a great job. It should be reflected in your tool that no, you have not done good job, because although you have reduced poverty, you have left a group or a group of people behind. That's the idea. This is what we want to capture. So how do we do that? Now, there is also an argument, theoretical justification on what we can do, what we cannot do. So until now, we know that we need to incorporate inequality or need to incorporate distributional issues so that they are not ignored. The question is, how do we do that? But before we go to that, the two practical properties that are quite useful for M0 is, first of all, ordinality. This is a departure, right? Because it tells you this is the real world data. In the real world data, things are not cardinal. They are ordinal data. Of course, fine. That's why that motivates the use of M0. The other one is dimensional breakdown. That means what you can do, you can break down the overall poverty across different dimensions to understand their contribution and changes over time. Then there is an impossibility result that is also there in the forthcoming paper of Sabina and James. It says that there is no multidimensional counting poverty measure that satisfies symmetry. Symmetry means anonymity, symmetry, permutation that you were talking about. Dimensional breakdown and dimensional transfer. So it is not possible for any particular poverty measure to be able to broken down across dimensions to understand contributions and at the same time capture this inequality or satisfy dimensional transfer property. So that's an impossibility result. We cannot do that. Not possible. So that's why M0 does not satisfy dimensional transfer in strict sense. In other words, one has to choose either measures that satisfy dimensional breakdown or choose a measure that satisfy dimensional transfer. You cannot have both. How to proceed? What should we do? Should we say, no, let's not use M0 because it does not satisfy? Let's use another measure, or there are some other tools that we can use to capture these distributional issues. So that's the focus of this class, and let's try to see what we can do. Suggestions welcome, because it's an ongoing area of research. So two possible way outs and practical way outs actually. First, use a poverty measure that satisfies dimensional breakdown, and then use another poverty measure that satisfies dimensional transfer and ordinality. So you use two different poverty measures. The problem is that is the reconciliation problem between, say, poverty gap and squared poverty gap. It's really difficult to reconcile both these two measures and relate them. You get from poverty gap, for example, those who has used poverty gap, you get a value of 0.5, fine. Squared poverty gap, you get a value of 0.29, fine. What is the relation between these two? It's unclear. It's really difficult to convey a policymaker, okay, I get the numbers, but so what? Okay. And the other option is to use a poverty measure that satisfies dimensional breakdown and ordinality, thus the M0 or MPI, its transformation, and then use or analyze inequality separately, analyze the distributional issues separately. So you use M0 because it has so many nice practical properties which others may not, it's intuitive, and then use, sorry, it's my phone. Stop it. Thank you. Very well. And then analyze inequality among the poor separately. Okay. So what are the tools that we have? So for the first approach that additionally use a poverty measure that satisfies dimensional transfer and ordinality, we know that it cannot satisfy dimensional breakdown. So M0 is ruled out. If you want something, okay, so you have to use two different poverty measures, M0 and another one. And there are different measures that has actually been proposed, even by Jairaj Subramaniam, who use a measure proposed by Chakrabarty and D'Ambrosio. Then Bosso Chakrabarty, D'Ambrosio has worked. So these are theoretical measures that have been proposed. Even Sabina and James has worked on a class of measures that satisfies dimensional transfer even a class of measures. I mean, so there are measures that exist, fine, theoretically there are measures that will satisfy dimensional transfer, but it will not satisfy dimensional breakdown. Okay? And other practical limitations, they are mainly used for ordering. So if you want to know this country or this region is better than this region, fine, this gives you a final ordering. The final figures are not intuitive. It's very similar to the Foster-Gear-Thorbecke 2 measure. You get a value of 0.0197. What does it mean? It's really difficult to understand. And also, these measures, I have not seen a large discussion on paying attention to subgroup disparity. In a sense, you have an overall poverty reduction, and I have presented in examples from, say, India, that overall poverty reduction has not been accompanied necessarily by a reduction, talking as a group, by reduction among the poorest subgroups. Indian states we have seen between 1999 and 2006, overall poverty was reduced even faster than income poverty, but poorer states did not reduce poverty well. Similarly, if you look at social groups, religion and caste, the poorest subgroup did not do very well. How are they captured? Because these integrated measures, so-called, they just capture the ordering and that's it, and they do not go much deeper to analyze these different issues. The second approach then, conduct inequality separately. Examples while studying child poverty in the counting approach framework. So De La Monica and Minujin and my colleague Jose Manuel Roche has followed their work later. They just use standard deviation. Okay, so they reported M0 incidence, intensity, and then computed the standard deviation among the poor to compute. Could be one approach, but it has certain limitations as well. The inequality measure, what it can do, what it cannot do. Okay, if you want to capture subgroup disparity, that requires you having a between group component that will capture between group inequality that standard deviation cannot do. It is not decomposable. Okay, so I'll come back to those things. So how this can be useful? It may provide additional information. Of course, you need additional information just going beyond incident and intensity. That we all agree. Okay. It can be used with a poverty measure that respects, of course, like M0. And if it is decomposable, as I was telling, you can capture the between group disparity and inequality among the poor both at the same time. So this is a descriptive tool. This is a sort of picture that we present in our country briefings. So if you have followed our country briefings, you will see we have, for each country, we present the distribution of intensities among the poor. Do you understand this picture? Have you seen? How many have seen this picture in our website? So what this says, so we take the example of Madagascar and Rwanda, which has very similar MPI, H and A. But if you look at the distribution, okay, this tells you what fraction of poor they're deprived in 33 to 40% of the weighted indicators. What fraction deprived 40 to 49%, 50 to 59%, and so on. Okay, so that is a descriptive tool that is also helpful. You can see a much larger fraction are deprived only 30 to 40%, whereas here you have much larger fraction of people deprived in or facing higher deprivation. Okay, so these are kind of tools that you can also use. They are available from the website. But when you really just want to know the answer, is this distribution more unequal or not? Or has this distribution become more unequal or not over time? It's really just difficult to plot all of them. It's just stochastic dominance results, right? You have to compare each pair separately. Here also, you just have to look each distribution separately. Oh, here it has gone, it's a little bit more, here it's a little bit less, this proportion is a little bit higher. So descriptive tools, they're fine to look at, but they are not going to provide you a final picture, a snapshot telling you whether inequality is higher or lower. Sometimes it is important to know. So what we will also do, we can use a separate inequality measure to capture inequality among the poor. And then the question is, which inequality measure to use? What are the typical inequality measures that you have heard about? Gini. Anything else? Sorry? Tail index that falls in generalized entropy class, right? Anything else? Sorry? Okay, perfect. Anything else? Atkinson's index. Perfect. All the inequality measures are coming out. Yes, definitely. These are the well-known indices. Perfect. So let's see what kind of inequality measure we find, and we find which we can justify or not. Let us consider an example before going to that case. Again, for simplicity, I just use a union approach. Now, suppose we have a vector C bar, which is obtained from a vector C. So we have two different vectors here, C and C bar. So you can see in C, you have again 5 persons. One of them definitely has no deprivation or somehow not poor. Then you have second person with say 4 out of 10, 4 out of 10, all 10 deprivations, all 10 deprivations. This is C. And then you have C bar. Suppose it has been obtained from C over time by reducing 3 deprivations among the first 2 and reducing 6 deprivations among the last 2. What would you say? I mean, of course, we can see that has poverty gone down? First question. Yes. And why?
Because the level of deprivation has gone down.
Perfect. So which property? We had a relevant property we defined. So which property suggests that? Transfer. Why transfer? It has gone, transfer is between, when you are transferring between. So it's dimensional monotonicity, which says that if somebody who is already poor and their deprivation goes down, then overall poverty should fall. So from that idea, any poverty measure that satisfies dimensional monotonicity, such as M0, will say that poverty has gone down. Perfect. No problem. Question with that? Please bug me, I mean stop me if you have any trouble. So the idea is that, so we all agree that poverty definitely has gone down. There is no single poor person for which poverty has, the deprivation has gone up. So poverty definitely has gone down in the society. How has poverty gone down? Any change in incidence? No, because 4 persons are poor. Change in intensity? The average deprivation share has gone down. If you take the average, it has definitely gone down. Inequality among the poor? Has the distribution become less? Sorry? How many of you would say it has gone down? Please raise your hand. And how many of you claim it has gone up? 1. Perfect. Any reason why do you think it has gone up?
Because the range between maybe C, maybe 2.5, and the range for C, and is 3.
So this one you are saying it's more unequal among the 4 than this one.
Yes.
Well, so I mean we disagree here. So given that we disagree, given that we disagree, of course we have the right to ask inequality of what? It depends on our value judgments, of course. The value judgments about whether it should be about the concept of absolute inequality. Remember, we talked about translation invariance and scale invariance. That means if you scale up like income, if you double everybody's income, people say inequality has not changed. Translation says you add $100 to everybody's income, inequality has not changed. And there is no single inequality measure that satisfies both forms of inequality, that capture both forms of inequality. Okay? And also a question is, if we are looking at across deprivation score or across attainment scores. Deprivation score means you count the number of deprivations, and as Uday has worked with Assam, they count the attainments, right? The satisfactions you count. So that's attainment. So you can either count deprivations or you count the complement, the attainments. Okay, and should it matter? I don't know. Let's see how we proceed. So inequality of what? Suppose first inequality is captured in relative sense. That means if everybody's deprivation score is doubled, whatever, then inequality should remain unchanged. That is the main idea. And if you capture that kind of inequality, that kind of transformation, that doubling deprivations leaves inequality unchanged, then you can use Atkinson, you can use Gini, you can use generalized entropy, which includes Thel measures, okay, any measure that satisfies relative inequality. Then inequality definitely has gone up. C has higher inequality. I am not going in details why, what kind of transformation is giving you, but you use any inequality measure. This is generalized entropy 2, which is the coefficient of variation. You can use Thel, you can use Gini, use any inequality measure which would say that this one has larger inequality than this one among the poor. Hard to justify, because you had 3 deprivation reduced, here you had 6 deprivation reduced. From a policymaker's point of view, it's really hard to justify that inequality has gone up. So you have incidence did not change, inequality, the intensity has gone down but by reducing inequality. And again, any relative inequality measure would say that inequality has gone up. So there is some issue here. We are getting something that is hard to justify. Then the question is, then are we looking at the wrong direction? Because when we are computing all these relative inequality measures, Gini, Atkinson, Thel, generalized entropy, note they come from the welfareist concept. So you have income, where larger income implies something better, right? And then you are capturing inequality. Here you are looking at deprivation scores. So larger means worse here. So we should not just blindly apply an inequality measure that is defined in the welfareist concept as more is better to more is worse. So then let's look at the complement. So let's look at the attainment side. So what we do, in order to do that, I subtract each of the deprivation score from 1.01. Why I do 1.01? Because 1 minus 1, 0, when you have 0 relative inequality measures do not apply. If you have Atkinson's measures or Thel measures, they do not apply when you have 0 incomes. So you must have positive values. So that's why, instead of subtracting from 1, I subtract from 1.01. So that those who are really highly deprived at least have some value, a positive value. So you get 1 minus 1.101 minus 0, 1.01, then they get 0.61, 0.61, and here you get 0.01, 0.01, and similarly you do 1 minus of this, you get this. Then we compute inequality. We used again generalized entropy. We could have used anything, and definitely clearly it shows that inequality has gone down. That is what most of you were expecting. So whether we look from deprivation side, whether we look from attainment side, it's just reversing the result. Is it desirable? Should it matter whether we count deprivations or whether we count attainments? I mean, let's forget about what we have got, but what do you think? Would you justify that? I mean, I can either count the deprivations or I just count the attainments. Should it matter for distributional issues? It's hard to justify if it becomes different. So I, instead of just looking at deprivations, I look suddenly their satisfaction or dissatisfaction. I just look at their satisfaction suddenly, and suddenly I said no, distribution is less unequal. Difficult. So then the question is then the right way to reflect inequality? Just look at the attainment score and use any inequality measures such as Atkinson, Gini, and all. Let us take an example. Suppose we have two distributions here. Here we are counting attainments. Okay, so we are not counting deprivations. So this 0.11 means this poor person has 9 deprivations. If we have equal weights, so this poor person has 9 out of 10 deprivations, this person has 5 out of 10 deprivations, and suppose over time this is what happens. You reduce 4 deprivations for this person and you reduced only 1 deprivation for this person. Has the distribution becomes more equal or more unequal? Here, you are for this person, you have improved 4 indicators. So, that means this person is deprived now only 1. Okay, and this person I have improved their attainment by 1. That means I have reduced the deprivation by 1 unit. Least improvement among the poorest, right? We have left the poorest behind here. Oh dear. Even then, if you do this, this one has been obtained by least improving the situation of the poorest. Again, if you compute any relative inequality measure such as generalized entropy Gini, you will see inequality has gone down. So, we had one problem that the extent, the direction of inequality is changing depending on whether we measure by attainment, whether we measure by counting by deprivations, counting attainment. That is one problem. The second problem actually is relative inequality measures do not work here. The concept income, it works in the income world where you do not have any upper bound. Okay, and you have the concept if I doubles everybody's income, if I change the unit of measurement, all these issues that motivates any relative inequality measure. What is the motivation for using relative inequality measure here? It may ruin things. So, then we try and ask the question, then before developing suggesting or devising a particular inequality measure, then the question is what kind of properties or what kind of value judgments we want this inequality measure to capture. And if I claim this one that we want, it went one. So, if we want the same level of inequality should be reflected whether across deprivation score or we measure across attainment score, would that be too wrong to ask? So, we have poor person's deprivations. Deprivations means we count, suppose somebody is deprived in 6 out of 10 dimensions, then the deprivation score is 6 out of 10, but the attainment score is then 4 out of 10. Okay? Because attainments are complements of deprivation. So, does it matter whether we count their deprivations or their attainments? Should we have different level of inequality from the distribution? If we do, why we do, I don't know. So, one value judgment that we can impose safely is the level of inequality should be the same level of inequality should be reflected whether we count their deprivation or count their attainments. And that takes us away from the world of relative inequality measures. That takes us to the world of absolute inequality measures, where the distance matter, not the scale. So, if you add one deprivation to everybody, inequality should not change. Or you take one deprivation from all poor, but the number of poor remains unchanged, it should not change. Okay? So, that brings us, so that actually eliminates all the inequality measures that we just spoke about. Atkinson, generalized entropy, Thel, which is included in generalized entropy, and Gini, all these well known measures, because they will all give that kind of conflicting results that I just presented. The second one, of course, one of our objective was to capture subgroup disparity as well, not just inequality among the poor, whether poverty reduction has been uniform across all groups. That requires a property that you have all seen in poverty measurement literature, population subgroup decomposability, right? Population subgroup decomposability allows you to break the poverty across groups and find overall poverty can be obtained as a weighted average of subgroup poverty. Similarly, in inequality measure as well, additive decomposability is slightly different. It says that the overall inequality can be broken into a within group component, inequality originating from within the groups, and inequality originating from between groups. So, if we have that between group component, we can capture the between group disparity in poverty. So we want our inequality measure to standard deviation does not satisfy this property. So you compute standard deviation, you get the overall level of inequality, then that does not allow you to say whether or what the level of between group disparity is. And there is a policy relevant property that we can discuss. It's called, we name it as within group mean independence. So it's sort of theoretical, but the idea is this: when we have this additive decomposability property, it divides the overall inequality into two components: total within group inequality and between group inequality. And the total within group inequality is actually a weighted sum of inequalities in each group. So suppose you have two groups, A and B. The between group tells you the inequality between the averages of these two groups. Within group is a weighted sum of inequalities within each group. That means a weighted sum of inequality within A, inequality within B. Now the total within group is a sum of inequalities within each group. Now if the inequality within group remains unchanged over time, should the total overall within group inequality change? Just like a consistent property, if the within group in each group remains unchanged, total within group should not change. So this is what this property asks, because there are some measures that actually, in which you will find that although the within group inequality did not change, but their average changed, the total within group inequality changes. But it doesn't make any sense. So these are the three main justification or three main properties or value judgments that we want to have. We don't know the inequality measure yet, but these are just a value judgment that you need to know or need to understand before even using a particular measure. Okay, so this is the idea. So this is just to give you go through an example. So suppose we have our overall deprivation score vector that you have C, and then we have two subgroups, C1 and C2. This could be two rural and urban areas. Suppose one is for rural and two is for urban. Then additive decomposability says that overall, if you want to capture inequality, the overall inequality can be broken down into total within group, and this is the between group. And this total within group is a weighted sum of inequality within rural areas and inequality within urban areas. Just think only in terms of, the deprivation score vector among the poor. Okay, suppose we're just trying to understand inequality among the poor. And now suppose somehow C bar you get another deprivation score vector over time where you have the number of poor unchanged, but somehow the deprivation scores change, but this has not changed the inequality within each group. Then the within group mean independence says that also if the population sizes remain unchanged, should the total within group inequality be different between C, this should be C bar, sorry, forgive me, should be C bar, not C prime. So if inequality within each group remains unchanged, then the question is whether total within group inequality should change. It should not. Do we all agree? Okay. So the inequality measure actually that we use that would satisfy this kind of value judgment is this. Can anyone tell me if you have seen this particular formulation somewhere? Yes? Loud please. You know that? It's the variance, right? So it's actually, it turns out that if you want all these value judgments to be captured, all these properties to be captured, the only inequality measure that will give you the desired results or desired formulation that you want is this particular structure, which is the variance. Now when I asked about inequality, of course it's some people may say, from welfareist approach, this is not exactly an inequality measure, it captures disparity. But in a world where we have the deprivation scores bounded, not unbounded, we do not have the possibility that our inequality measure is going to explode, why not? And given that it is giving us desired results, yes.
I mean, one solution to get around this is to take the logic transformation, and then you will transform 0 into an unbounded interval, and then you can do all of this stuff on the unbounded.
In the unbounded case, but here it is bounded.
Yeah, but if you take the logic transformation,
Yeah,
then it
if you,
becomes unbounded, and then you can do all of this.
that's an income world you are talking about. Yeah. In income world you could do, but here
In your C matrix.
in the symmetrics, there are certain things actually COMB has a whole class of indices. The problem is that the weights to the within group component, they do not sum up to 1. It's a convex combination and it does not satisfy the within group mean independence property, which means so that would be the only problem. So if you avoid that problem, then this is the only measure to use. So that's why I presented these measures, but thank you so much. Yes. So the suggestion was to take a logic transformation, and it's actually a class of indices that COMB had proposed a long time ago, and many people had worked in the absolute inequality measurement world. But the problem is that, as I presented to you in the previous slide, these weights generally weights sum to 1. I mean, even when we are working, in the world of population subgroups, in general weights sum up to 1. And in the case that was proposed, logic transformation, these weights depend on means, first of all. So it does not, if you take those kind of transformation, it does not satisfy this particular property. So it is possible that even though the within group inequality remains unchanged, total within group inequality will change. So that's not very policy relevant. Okay, so that's why we rule out those cases, and we are left only with this particular measure, where you have, this is called a positive multiple of variance within a distribution. This is the average of the distribution, and you have the number of elements in the distribution. This is beta tilde. Sorry, this is not alpha. This is going to be beta tilde, this parameter. So this is one thing that we could do, and this is what we came up with that satisfies the value judgments that we just spoke about. Now somebody may disagree with these value judgments, but need to come up with a proper argument why somebody would disagree and what alternative one would want. Now if one can properly justify that these value judgments are not correct and what we are proposing is correct, then you can use a separate inequality measure. Of course, you have to justify why you are using it. But if we want to capture inequality across deprivation score or among subgroup disparity in the counting approach world, this is the only tool that you can use if you want to get a final inequality measure, whether it has gone down or gone up. Now what we can do with that, you can break it down into a total within group component and total between group component. This is a variance, allows you. So the L, the small l's, see they are missing here somehow, cannot read. The small l is called the Lth subgroup. So you have total m number of subgroups, suppose, and then that's L, script L denotes the particular subgroup. So L is equal to 1 to m. And this is the share of those elements in this particular group. Now two applications. Inequality among the poor just can be calculated by, and we denote it by IQ, and it can be calculated by just looking at the deprivation scores among the poor. So not all elements, you have n elements, right, n population, you just take the q elements, poor, and you compute variance, and this is A. What is A? The average deprivation scores among the poor is the intensity, which is denoted by A. M0 is equal to H times A. So you use the deprivation score, subtract from A, takes its square. This is how you compute. So in Stata, if you are willing to compute, you can compute. You can compute for the overall poor, even we can compute the variance for each subgroup to check whether inequality has gone up, gone down over time, although you are not doing the time series analysis. And the other one if you want to compute, we denote it by IN, if you want to compute inequality across population subgroups, in a sense is disparity, it's not inequality actually, it's disparity across say subgroup M0s. We have already presented, right, when we are presenting the case of Nigeria and India, you saw the average M0 was something, but there was huge regional disparity. How to capture that? That can be captured by the between group component, and we denote it by IN, which is equal to the population share of each subgroup, and then you use the M0 of subgroup L minus the overall M0. Square them up, sum them up, you get the disparity. Okay? So these are actually the between group. This comes from the between group component. Then you may ask, why disparity in poverty across subgroups important? Of course, one justification could be to avoid horizontal inequality. Of course, you do not want any particular group to be left behind, and this gives you a monitoring tool to capture whether disparity has gone up or gone down or is really high in certain countries. And it may be possible actually that the overall inequality and within group inequalities in all subgroups fail, but still disparity in poverty increases. So you can have this kind of situation. It may be rare, but you may find this kind of situations, and this tool allows you to capture such kind of things. So let's take an example that is also available in the book. We take beta tilde is equal to 4 just to normalize the overall inequality measure to lie between 0 and 1. And so in the first example, you will see between Yemen and India, oh dear, stopped working. So for Yemen and India here, you will see the same level of M0, okay. It's really hard to distinguish statistically significantly A and H, but this is statistically significantly different, the inequality. Also, this actually remains same. They have 21 region for Yemen has 21 region, India has 29 regions, and disparity across regions they're almost similar. The other example we consider between Togo and Bangladesh, which had similar level of M0, H and A, even similar level of inequality among the poor. However, even with the same number of regions, which is 6 and 7, disparity, subnational disparity across M0s, they're quite different. So this is how you can use the tool. So I'm just using only one example. We are going to post the paper soon, which has several other examples. We try to go through the case of Haiti and India, the time series analysis, and show how inequality has, inequality in distribution, among the poor has changed over time. It's quite contrasting. In Haiti, we find that overall poverty reduction has been accompanied by reduction in inequality, even reduction in inequality within each subgroup, and disparity across M0s has also gone down, which has not happened in case of India, where strictly inequality in certain state has gone up. Inequality, if you look at overall disparity across states, this has gone up over time. Quite contrasting stories that we find. So of course, when we look, so to summarize what we just saw, so the beginning point is that you need to capture distributional issues. We cannot just ignore that. We cannot just say, no, let's focus on M0, let's focus on incidence and intensity. We don't care about distributional issues. No, they matter. You may find empirically for some countries, well, reduction in poverty has accompanied by, reducing distributional concerns or is improving distributional issues. It has happened automatically, fine for those countries. But it is not necessary that this is going to happen. So that's why it is required that you also understand the distributional issues across the poor, just beside reduction in poverty incidence and intensity. So it is a requirement, and the question is how to do it. If we do it using or proposing another poverty measure that satisfies inequality, then we have to give up the dimensional breakdown property. So we have to choose any one of them. And the question is, can we create sort of a framework? And also these integrated measures, as we said, they're not intuitive. You get a final figure, fine. Then what? What is the meaning of this final number? It's difficult to justify. So then what are the other options? We may try to analyze inequality separately. You could use descriptive tools, but then it does not give you a definite figure. You cannot say, you cannot do statistical test or whatever, you just get visual pictures. That's it. Then if you want to use a separate inequality measure, what to use? That was our confusion as well in 2011 when we were trying to do it. We used different measures such as Atkinson, generalized entropy, Thale, and some results were striking. We did not understand at first what we were doing. But some of the results, for example, for India, I was working on India, and somebody else, Nicole Ripin, has also worked on India, and it presented that in Kerala, which is one of the best performing states, had a massively higher level of inequality among the poor compared to a state of Bihar, which we know has huge problem in that state, at least in that period. And so that's when it struck us. How could it happen that you are saying 3 times more inequality in the state of Kerala than in Bihar? Then we tried to understand all these justifications, and we found all these problems. The 2 main problems, first is that if you measure or if you count the deprivations of the poor, or you count the attainments of the poor, honestly that should not matter. But if you use a relative inequality measure, you will get contrasting results. One will say it has gone up, one will say it has gone down, because all these inequality measures comes from this welfarist approach where it is assumed more is better. So applying those measures on deprivation score, they're not the right approach. Then you might say, let's do the attainment thing. Let's apply an attainment score. Again, the relative concept does not work very well over there. So one of our value judgment was that it should not matter how we measure, we should get same level of inequality, whether it's through deprivations, counting the deprivations, or counting the attainments. And then we also had 2 other policy relevant properties. One was additively decomposable, and the other one is that if you do not have any change within each group, the deprivation score, total within group inequality, should not change. And that leaves us only one choice. It's an absolute inequality measure, and that's variance. It's well known. Everybody knows variance. But also note that this particular formulation is different from the way you compute sample variance. For sample variance, you divide by 1 divided by n minus 1. You divide it by n minus 1, right? If you do it, if you just compute from stata, the standard deviation or variance, it will divide by 1 by n minus 1. And that will not satisfy the population principle. Okay, population principle is that you replicate the population, your inequality remains unchanged, doesn't satisfy this particular property. So we use this particular formulation. It's called a positive multiple of variance, but it divides by n. So please do not compute. We faced that problem when we were writing a book for the World Bank. We tried to compute the generalized entropy, the coefficient of variation square, directly from stata. So the stata computes the standard deviation, and we use that to compute things. It's for the ADEPT software available from the World Bank website, and we found they were not giving us the results desired because it was dividing by n minus 1 and not dividing by n. So if you need to compute, you just need to write separately the program by yourself, but it should not be difficult. You compute the averages you use egen, then you have the deprivation score, you compute the difference, square them up, and just average them, and then you know how to normalize. This is how you can compute easily using stata if you are trying to compute. So the added advantage, of course, then if you use this separate inequality measure, that of course it shows same level of inequality, whether you don't have to worry about whether you measure by attainment or deprivations, it's fine. And the tool can be used to assess and monitor disparity. This is another thing that you cannot do with integrated poverty measures. Integrated poverty measures, what they do, they just compute, say, poverty level for each group, fine, and you get a snapshot. You have 30 regions. You do not actually know. You cannot summarize just looking at them whether poverty has gone down or gone up. You can check from 1 or 2 regions. You don't get an overall figure that this inequality measure may provide you. Okay, so I stop here. Questions and comments? Yes, please. Just a minute. Thank you.
Thank you. I'm just wondering in my mind that it's good we've been computing MPI that deals with proportion of poor in the population as well as the level of deprivation that they suffered. But looking at inequality, we are still focusing on the poor again, looking at inequality among the poor. I'm wondering of what use is that to the country for the development when we are still looking at the poor, inequality among them, they are already sinking, and we are still looking at them instead of comparing them, the inequality between the poor and the non-poor. So I'm just thinking, what use is this to the country?
Yeah. Definitely the important question is to look at the overall inequality. No question on that. You can look the difference between poor and the non-poor, and if you go to the income world, definitely you can look that, or you can use other variables to look that. That comes from the idea of well-being. You measure the well-being and you capture inequality within the well-being. The main issue, I'm not saying that when you are reducing poverty, it may happen that the poorest of the poor has been assisted directly. But you would agree that even among the poor, there are large variations, right? And it is not only that, it is also that whether poverty, the fruit of poverty has been shared by all subgroups. It is possible. I mean, what is the objective? You cannot remove poverty in one day. You cannot remove poverty in 1 year. It's a gradual process. It takes time. And it's also need to know whether this gradual process is going smoothly and reaching to all, because it creates frustration. It's the example of 2 lanes. If you are standing in a lane with a car and your car is not moving, but in the other lane the car is moving really fast, you would always try to jump to the other lane, and that would create commotion. Same issue here. When you are reducing poverty probably a particular group or region, but the other region nothing is moving. So your overall poverty reduction, it's showing it's a gradual process and it is gradually going down. But it is not going down uniformly across all groups. And that can create commotion. So that's why it is important to note, to keep the process smooth. That's why distributional concerns are, I completely agree with you, inequality, overall inequality should be the major concern. But here also, you cannot leave it out. You cannot leave it out the distributional issues. To ensure that things are going smoothly, you need to capture that distributional issues. Yeah.
Is there some measure to...
Wait just a minute. Let's take the mic so that everybody can hear.
Is there some measure to take in account also the disparities between, because that's it, I think it's useful if we are working, because we are working with dummies, but in some case we have continuous variables, and in that case, for example, for assets.
You mean dummies mean the binary variables, you mean? Okay.
Yeah, but what if?
Yes, okay.
But what if we are taking in account that it's deprived if it has less than 3 assets? And what if one has 1 asset and not, but or 2 or years of schooling inside?
So you want to capture the differences. So instead of just doing 1 on 0, you are trying to assume that you have the values of the achievements of the. You do not dichotomize your data. You could. The thing is that when you are using ordinal variables, of course, you do not know the distance between different categories, right? I mean, there also transfer does not make any sense. Gap or squared gap is one way of capturing inequality. Then also the problem is that what value do you assign to those categories? Okay, years of schooling, suppose you assume that the difference between 1 year of schooling and 2 years of schooling is 1 is which is equal to the difference between 2 and 3 years. I don't know, it's a valid assumption to make. But if you make that kind of assumptions, you can go ahead and use gap measures, even Sabine and James's measure, the M2 measure, which is the average of squared gap. You can use that kind of measure directly to capture inequality, within dimensions. But you have to make certain assumptions that they are meaningful. Okay. Yes, please.
Just how do you interpret the beta coefficient in the formula?
Right, beta is sort of a normalization coefficient. So the idea is that definitely if you find a inequality value of 576, how to interpret that? We do not know. So we want to normalize it between either 0, 1 or 0, 100, so that we say 0 means lowest level of inequality, 100 means highest level of inequality. Now variance has a maximum and minimum value. So if you have the range is 0 and 1, or say A and B is the range, then the maximum possible variance is probably B minus A whole square over 4, something like that. So if you have a range of 0 and 1, the maximum possible variance you could have is 0.25. So if you divide or by the thing normalized by 0.25, it is you make the possible range of the inequality measure between 0 and 1. So this is how we do. So you can use that maximum value, possible value that you allow in the deprivation score and normalize by that. So you choose beta tilde in that way. Good. Any other questions, comments? Thank you so much. I will be here, so if you have any other concerns, questions, please feel free to come to me and talk.